Hello everyone, in this video we are going to talk about the inner working, the architecture of ChatGPT. Most engineers look at ChatGPT and see an API, a single endpoint. You send a string, you wait for a few seconds and you get a string back. It feels like a function call, a very smart, a very expensive function call. But that mental model is an illusion. Behind that single post request lies one of the most complex distributed systems ever built. It's a world of dynamic GPU orchestration, multi-stage alignment pipelines, and inference optimization. This all are fighting together against the laws of physics and economics just to give you that answer for your prompt. And today we are going to look past, have a complete overview, and we are going to talk about the hidden architecture of ChatGPT, not as users, but as architects, but as engineers. So before we move forward in this video, it is really important to understand and frame the problem correctly. There are a lot of misconception about AI, about ChatGPT. And the biggest misconception in AI today is that model is everything, model is the product. But when you use ChatGPT, the model, which is GPT, has the weights, the transformer, it is just the engine. But an engine, you need to understand, it can't move a car itself without transmission. We need fuel, we need automatic, manual, this many stuff. Similarly, in a production environment like OpenAI, the model is actually the most fragile part of the stack. It is non-deterministic, it is computationally heavy, and it has no inherent sense of time, state, or safety. So to run a raw transformer, to transform something, a transformer into ChatGPT, you need to wrap it in a system that can manage state across millions of concurrent conversations, that enforces policy in real time, and that optimizes for a metric that the model itself doesn't care about, which is latency. So if you are an architect, you should not ask how does the model work. You should ask, how can we serve this model to millions of people without infrastructure melting, without infrastructure breakdown. So that is the thing we are going to look at. We are going to understand the architecture of ChatGPT. Before we move forward, let us have an overview. Let's look at the bird's eye view. The ChatGPT architecture can be broken down into 4 primary pillars. First one, orchestration layer. This is the brain of the product. It handles session, it manages which query, it handles your chat history, it decides which version of model to route for your particular request. So it takes off every routing, every history thing, which is orchestration layer. The second one is inference engine. In inference engine, this is where the GPU comes in. Like a lot of massive GPU works together to give you that answer. And there are various techniques that we use, like batching, page attention, are used to give and use every possible token, right? And this is where the answer comes in. This is the place where your answer cooks in. Like when you send a prompt in inference engine, your query will get processed and then the answer generation will take place. So in inference engine, it's like a kitchen where your food get prepared, where your answer get prepared. Okay, now the third pillar of ChatGPT is safety. Your prompt, before your prompt even touches the model and before the response generated, it passes through a series of secondary model designed to detect jailbreaks or harmful content. And the final one is feedback loop. Every thumbs up, every thumbs down you give isn't just UI element. It's a data being fed into the multi-stage alignment pipeline that includes supervised fine-tuning and reinforcement from human. So every time you give a like, every time you give a dislike, the model is understanding which answer to give. So the thing is, we need to understand that none of these 4 pillars sit together. We need to create a system in such a way that handles latency, that handles accuracy, and it can scale with complexity. So these are the things that we should look at. And like there's one more terminology that everyone should look at, which is whenever we talk about LLMs, there are 2 terminologies which comes in, which is training and inference. These are the two terminologies that every other person should understand when they talk about training, when they talk about LLM. Now, the thing we need to understand is training is the input data that we give to the model while building the model. It's the initial data set. You can imagine as an initial data set. Here we insert massive data into the model. The training happens every few months. It's a very slow process. It takes time, and what we do is that we take a data set, we insert that data into the model. Whereas inference is a latency problem. Now we have the all data set, we got the question, so based on your prompt we are giving predicting answers, that is known as inference. But here the architectural catch is LLM inference is auto-regressive. What does that mean? So you need to understand that when generating answer, at the very core of ChatGPT we have a transformer, right? Like GPT model is built on transformer, and there's a problem. Like if you study, I'll make sure that I'll make a video of in detail video of transformer. It is really important to understand the architecture of transformer before we go deep dive into understanding models architecture. So let me give you a very quick, very small summation of how a transformer works. So a transformer is basically a combination, a very complex combination and computation of neural networks. So when you combine n number of neural networks, you get a simple transformer. But the work of a transformer, you need to understand that it takes a string, it gives you output string. That is very simple to understand that a transformer, the work of a transformer is it will take a string, it will give you a string as an output. Okay, got it? Now the problem with transformer, we call it as mathematical curse, right? And that curse is it cannot understand or it cannot remember long sentences at once. Like for example, if I'm giving 1,000 words to a single transformer, then it will never ever remember all this 1,000 words. It cannot, because it has the inability that it cannot have multiple tokens at once. It can only remember up to 3-4 characters, that's it. Apart from that, transformer cannot. Now the thing is, GPT or Claude or all this models we see, AI models we see nowadays, is built on transformers. Right? They use transformer architecture. Now, if transformer don't have memory in itself, then how can we sending 1,000 lines para to ChatGPT and it is giving answer? So here we have the data set, and the inference is the main problem, right? Because we are using transformer, the answer generation is really complex and hectic task. So to handle that, we use something called as auto-regressive process. What is this auto-regressive process? So to understand auto-regressive process, you need to understand that I hope you guys have understood what is training, what is inference. Training is the initial data that you give to the model, and inference is the process through which you generate the answer for user query based on the data set we have. This is the difference between training and inference. Okay, very simple to understand, very easy. Now we encountered a problem, which is transformer can't have memory. It cannot store thousands of lines. It cannot memorize that. But at the end of everything, we have transformers only. So how you gonna make sure that you are giving right answers even the memory is getting loosed? This is where we use auto-regressive process. The meaning of auto-regressive process is that, let's say I have given a query and my output, my model is generating answer. So you need to understand that every model, when I speak specifically about ChatGPT, like every word is dependent on the previous word. This is the meaning of auto-regressive. So let's say it is giving my name is Jabir Hussain as output. Okay, I have asked ChatGPT what is your name or what is the user's name. It is giving my name is Jabir Hussain. Now you need to understand that here the initial word is my. Now after that it will calculate, okay, the next word should be my name, right? Because the name makes sense with respect to the previous word. So every nth word is dependent on n minus one word. Like this, what will happen is we are not putting overload on transformer, right? Transformer is storing very few words, but every word is interlinked with another, like other words, previous words. Like this, we use this process to give proper thousands of lines of answers. And in backend, what we use, which data structure we use key value pair, we use hash map. Every element in hash map is connected to one another, and every key value pair, the key will be current word and the value would be previous words, previous 2-3 words. So based on previous words, our next word will get decided. This is how the auto-regressive process works in LLM. And we call this data structure, we call this memory system as KV caching. So I hope you have understood the difference between training and inference, and how inference used to generate thousands of lines of answers. Now let us talk about the data pipelines. We often hear that ChatGPT was trained on the old internet, but the raw internet data is noisy, toxic, and often wrong. The ChatGPT personality we have is a helpful, harmless, and honest assistant, and is created in the alignment phase. Architecturally, this is a massive data engineering challenge. It starts with supervised fine-tuning, where human experts write high-quality answers to the prompt. Then comes clever part, which is RLHF, reinforcement learning from human feedback. OpenAI doesn't have human right answers. They have human rank answers. Is answer A better than answer B? If answer B is better, then give that answer to user. This is how the answer generation works. This ranking data is used to train reward model, a smaller model that acts as a digital judge. Then the main model is played against the judge in reinforcement learning loop. From a systems perspective, this means your data pipeline isn't just one-way street. It's a closed loop where human feedback is constantly being distilled into human weight. The architecture has to support this continuous cycle of evaluation and deployment. So every prompt will go through multiple evaluations. So this is how the pipeline, the system works. Now let us talk about the main core, which is the model of GPT. At core, I have told you, it is a transformer, but not all transformers are equal. While the exact details of ChatGPT are proprietary, the industry has moved towards a mixture of experts. We call it as MOE architectures. In traditional dense model, every parameter is activated for every other token. That is, you need to understand, incredibly expensive. In an MOE architecture, the model is divided into experts. For every given token, say a word about Python code, only a small set of those experts will get activated. This allows the model to have a massive knowledge capacity, like maybe trillions of parameters, while keeping the compute cost per token relatively low. But MOE architecture brings a new architectural headache, which is how you can route to different experts. You need a router layer that decides which experts gets which token. If the router is inefficient, or if one experts get overloaded, your inference speed plummets. As an architect, as a developer, you're constantly balancing the trade-off. Do we use a smaller, faster, dense model, or a massive, sparse MOE model? So it's a really routing problem. It's a really developer's mindset, right? Now let us talk about serving at scale, right? What happens when 1 million people hit enter at the same time? If you served one user per GPU, right? If one prompt is taking one GPU, then OpenAI would go bankrupt in an hour. So you need to use batching. You need to divide every prompt into different batching. But traditional batching doesn't work for LLMs, because different user generates different amount of text. If user A wants a haiku and user B wants a word essay, the GPU would normally wait for the longest request to finish before starting the next batch. This is called fragmentation. The solution is continuous batching. As soon as one user's token is generated, the system inserts a new user's request into the slot in the GPU. To make this even more efficient, system uses paged attention. I will attach a paper of page attention, you can read it out, inspired by virtual memory in operating system. Paged attention allows the KV cache, we have talked about KV cache in just few minutes ago, to store in a non-continuous memory blocks. This reduces memory waste by nearly 10 to 15%, allowing far more users to share the same GPU. It means that making it smart, like you're making it smart, was a breakthrough. Making it fast and cheap is a system engineering masterpiece. You are allowing the same GPU to give multiple answers for multiple users. So this is the serving at scale problem. Now let us talk about what is the cost, what is reliability and failure models. So AI systems are, you need to understand, it is inherently unreliable. They hallucinate, they drift, and they are sensitive to temperature, the randomness of their output. In a traditional software, if something returns, you have a bug in your logic. If something errors returns, you have an error. But in AI system, if model says something false, it might be just statistical outlier. At the end, it's a probability curve, it's a normal distribution. So architecturally, we have to handle this guardrails. They are input guardrails that sanitize your prompt to prevent prompt injection. And they are output guardrails, often other foster models that check the response for a factual inconsistency or policy violation before you see it. Then there is cost. Every token has a price tag in electricity and siliconware computation. When the system is under heavy load, the architecture might downgrade to a lower and faster model like GPT-o1, GPT-o-mini, or increase the aggressiveness, use of speculative decoding, where a tiny model guesses the next few tokens and the big model just verifies them as a whole. So reliability isn't about making the perfect model, it's about building a system that can handle an imperfect model. That is where efficiency, cost, all these terms comes in. Now let us come back. We started with the API. So why does OpenAI gives us API? We have understood how a ChatGPT works, what is the architecture, transformer, everything. Now, why hide this complexity? Because the abstraction is what makes the ecosystem. If every developer had to manage GPU memory paging, KV cache eviction, and reinforcement human learning feedback loops, AI development will crawl to halt. The API, which is ChatGPT API in our case, is a stateless interface to a stateful system, right? It hides the fact that your conversation is actually being constructed from a database, passed through a safety filter, routed through a GPU cluster in a specific region, and optimized via speculative decoding. All in the time takes to blink your eye. But as we move forward, agentic workflows where AI is calling other APIs and making decisions, this abstraction starts to leak. Understanding what is under the hood becomes a competitive advantage for engineers like you and me. So with that being said, I hope you have understood the overall architecture. I hope you have understood the basics of how a model works. So the next time you see ChatGPT, you should not just think about the AI, think about the architecture, think about the engineering that goes beyond. Think about the millions of lines of C++ and Coda that makes the inference possible. Think about the human feedback loops that shaped the model personality. Think about load balancers that are split seconds, that are making split seconds decision about your request, right? The future of AI isn't just building bigger models. It's about building a system. It's about infrastructure that makes intelligent utility as reliable and accessible as electricity. Everyone should have access to AI, everyone should have access to every other thing. So if you want to build the next generation of AI tools, stop thinking like a prompt engineer. Start thinking like an architect. Start thinking from a systems perspective. Start breaking down every other nuance and understand every little detail. Right? Pay attention to detail in a world where there is no attention. So with that being said, thank you for watching. I hope you have understood each and every nuance, at least a little bit of ChatGPT. So thank you for watching. I will see you in the next one.